Pre-statistics. Using the TI-84 to solve one-variable inequalities. Lesson objectives. Use the TI-83 or 84 to determine if an inequality statement is true or false. Number 2. Solve one-variable inequalities using the TI-83, 84. And we'll do this by using the graph and table commands. Let's begin. In mathematics, Boolean algebra is the branch of algebra in which the values of variables are truth values, true and false, usually denoted by a 1 and a 0. The TI-83-84 calculator can perform Boolean algebra, including statements involving inequality symbols. If a statement is true, the calculator will report a number 1. If the statement is false, the calculator will report a value of 0. So let's do a few examples. So we have to know where to find the inequality symbols on the calculator. If you look above the math key for test, this is where the inequality symbols are. So if you hit second and math, we have a list of the 4 inequality symbols, and we also have equal to and not equal to. Okay, and again, if I want to get out of this screen, I go to quit, which is second mode. So let's try an expression. Is 5 greater than 3? 5, and then we want to go to our test window, which is second math. We want number 3 for greater than, and then we want the number 3. So is 5 greater than 3? And of course the answer is yes. So the calculator, once I hit enter, should report back a value of 1 because it's a true statement. And it does. Let's do a false statement. Let's try is 5 less than 3? 5. Then we go second math, which is our test window. This time we want less than. So that's number 5. Then we type in our 3. Of course, this statement is false, so the calculator should report, once I hit enter, a 0, and it does. Let's do one more. Let's say negative 1 is greater than or equal to, which is number 4, to negative 3. And of course, negative 1 is greater than negative 3. It's not equal to, but it is greater than, so this should report a value of 1, which it does. Lesson objective number 2. So we are asked to solve and graph the following inequality. 3 times the quantity x minus 1 is less than or equal to 9. To solve this algebraically, we would first distribute the 3, and we get 3x minus 3, and that's less than or equal to 9. Next, we would add 3 to both sides, and we have 3x is less than or equal to 12. And finally, dividing by 3, we see that x is less than or equal to 4. On a number line, we would go to 4. It can equal 4, so therefore 4 is a solution. We would want a solid dot on 4, and then we want all numbers less than 4. So this is how we would solve it algebraically. Let's try it using the graphing calculator. So our first step, we would go to the y equals. We type in our inequality, 3 parenthesis x minus 1 close parenthesis. Now we need to insert the inequality symbol here. So we go second math, which is the test window, and we want less than or equal to, which is number 6. So this pastes the inequality symbol into our y equals, and then we want to type in finally 9. For the values of x where this is a true statement, the calculator is going to report a 1. For values of x where this inequality statement is not correct, it's going to report a value of 0. So finally, we hit graph, and we can see all these x values here are equal to 1, and as soon as we get to this point, 4, looks like the values become 0. We can verify this using our table command, which is second and graph. Now my settings here are not correct, so if I go to second and window, which is table set, I can tell it to start at 0, and for my table count I'm going to choose a 1. So now I hit second and graph again, and we see values less than 4 report a 1, and since 4 is less than or equal to 4, it reports a 1, but as soon as we go beyond 4, we get a value of 0. It may be wise at times that we want to not count by 1, but maybe a half or a tenth. And again, we do that by going to table set, second window. This time let's start at 4, and let's count by 0.5. So we go back to our table, and we see when x is 4, we get a true statement, but 4.5 and beyond, these are false statements. So we've just verified the answer that we solved algebraically. Let's try another example. Now we have the inequality 6 is greater than negative 2x plus 4. To solve this algebraically, we want to get the x all by itself. We need to get rid of the 4 and the negative 2. Following the order of operation backwards, we get rid of addition first. We subtract 4 to both sides, and we have 2 is greater than negative 2 times x. To cancel the negative 2, I do the inverse operation, which is division, and we divide both sides by negative 2. Now if you recall, if you divide by a negative number, you flip the inequality symbol. So we have negative 1 is less than x, and it's good math manners if we write the x on the left hand side. So that's the same thing as saying x is greater than negative 1. These two statements are equivalent. They are the same thing. Negative 1 is less than x, and that's the same thing as saying x is greater than negative 1. On a number line, we go to negative 1. It's greater than negative 1, so it doesn't equal, so this will have an open circle, and we want all values that are larger than negative 1. So this is what our graph would look like. To verify this using the graphing calculator, we go to our y equals, hit clear. We want to type in our inequality, 6 greater than, so second math is the test window. We want greater than, which is number 3, negative 2x plus 4. Now we hit graph, and we see values that are greater than negative 1 are reporting a value of 1, which is a true statement. Values equal to or less than negative 1 are reporting a value of 0. They're graphed on the x-axis. Let's look at this from the table. Second graph is table. Let's go ahead and change our starting value and what we count by. So that's table set, second window. I'm going to start at negative 2, and again I'm going to leave it 0.5. Back to table. When x is negative 2, we have a false statement. Y is 0. Negative 1.5, it's still 0. When x is equal to a negative 1, it's a false statement. But as soon as we start getting values bigger than negative 1, the calculator is going to report a value of 1, which is a true statement. So this agrees with our solution of x is greater than negative 1. Let's do one last example. The last example, 4 minus 5x is greater than 0. To solve this inequality, I need to get x by itself. I need to get rid of the 4, and then I need to get rid of the minus 5. Subtract 4 to both sides, and we have negative 5x is greater than negative 4. Then we divide by negative 5, and we get negative 4 divided by negative 5 is positive 4 over 5. And since we divided by a negative number, we flip the inequality sign. So this is telling us all values that are less than 4 divided by 5, or 0.8. 4 divided by 5 is 0.8, will be a solution. So on the number line, we go to 0.8, and we want values less than that. We have to have an open circle here because this is not a equal to sign. This is a what we call a strict inequality. So all values that are less than 0.8 will make the inequality a true statement. Using our graphing calculator, go to our y equals, we clear out our previous example, type in 4 minus 5x is greater than is number 3, 0. Hit graph, and here we see it's close to a positive 1, but it's a little bit less, so this would be at 0.8. All values less than 0.8 are returning a value of 1. If we go to our table set, let's start it at 0, and let's count by 0.1. So all these values are returning a value of 1, and as soon as we get to 0.8 and greater than 0.8, the calculator is giving values of 0. So this verifies our answer that we got when we solved it algebraically. X is less than 0.8. Thanks for watching.